Hello everyone, let's try to solve one more question which came in JEE Mains 2026 from the chapter Amines. So I'm solving the questions whichever came in Amines in 2026. So we have solved one question. Now let's try to solve this particular question. And overall, from Amines chapter, 12 questions came. So based on like they were repeating the reagents, they were repeating the concepts. Like I'll tell you, fine, like at the end after solving these 12 questions I'll again let's analyze like what type of questions they were asking from this Minds chapter. Okay, so here we have solved this question. I hope you have watched that particular video, and if you get any doubt or if you get stuck in any concept, you just let me know. And so yeah, let's try to read the question once. Here this came on JMain 2026 21st Jan. Okay, let's read the question once. Here, an organic compound P on treatment with aqueous ammonia under hot condition forms compound Q, and here, which on heating with Br2 KOH forms compound R having molecular formula they have given for the R. Okay, let me write it over here. So we have product P and we have this organic compound P, and they have treated with this aqueous ammonia under hot conditions means heat also they have mentioned, and then we have got this Q, and on treating Q with the bromine Br2 KOH we'll get product R, which is having a molecular formula C6H7N. Okay, and here after seeing this reagent you might have got an idea. This is a Huffman bromide degradation, HBD reaction. Okay, so this is an Huffman bromide degradation. Okay, so here as they have given molecular formula for R, let's solve this conversion from reverse order. This is called reverse engineering, or you can say retrosynthesis. So you need to so let's say, see, as the given molecular formula, let's try to find out the degree of unsaturation. What is degree of unsaturation? If you find out that particular thing, you'll get to know how many rings and pi bonds are there in that particular compound. Okay, so here for degree of unsaturation the formula is C plus 1 minus H plus X minus N by 2. You can directly you can directly calculate it, but for your reference I'm just writing the formula. Okay, here 6 carbons are there, 6 plus 1 7, minus hydrogens are 7 and 1 nitrogen is there, so minus 1. Halogens were not there, so that's why it will be 0 and it will be by 2. And here 7 minus 6 by 2, which is 3, and 4. So we got to know like 4 means there will be a benzene ring. So what is the degree of unsaturation of this benzene ring? How many pi bonds are there? 3 pi bonds, and one ring is there. So degree of unsaturation of this benzene ring is 4. So whenever you get 4 as a degree of unsaturation, most probably benzene ring will be there in that compound. Okay, so here you have understood like this should have a benzene ring. If you draw the benzene ring, what else left? One nitrogen left, and here this benzene ring also contains 6 carbons. So here this also contains 6 carbons. If you write this aniline, I mean here NH2, let's check. Here one hydrogen, 1 2 3 4 5. So 5 hydrogen, 6 plus 2 7. So 7 hydrogens and 1 nitrogen and 6 carbon. This is getting satisfied, right? So R should be aniline only for sure. And now you can check the options also. Here they have given 2 methyl aniline, means you can write the thing over here. See, 2 methyl aniline looks like this. This is aniline, and here on second position with respect to this group, here there will be one methyl group. Here one carbon, one methyl group is extra, right? Here it will be C7, but here we have only 6 carbons, we don't have 7 carbons, so that's why you can just simply eliminate these options. If you don't know what are the structures of these things, you can just simply see the last product and you can eliminate these options. See how easy to solve these questions. And here they have given aniline, so this might be the answer, correct answer. Okay, so here also they have given 4 methyl aniline. What is 4 methyl aniline? Aniline here with respect to this aniline group. on fourth position, which is para, there will be a methyl group. And again, one more extra methyl group is there. It will be C7. But here there are 7 carbons, but we just need 6 carbons for the product R. So you can eliminate this option also. And in the next question, like in the next option, they have given benzamine. There won't be anything like a benzamine, but it might be a benzylamine. Okay, so let's see. You have understood. You can eliminate these two options. Now let's check option B once. Okay. So here in option B, we have benzoic acid, which is C double bond O COH, right? C double bond O OH. This is the benzoic acid. Upon treatment with this aqueous NH3, generally when you treat this benzoic acid, when you treat acid with NH3, this is an acid based reaction. It will form ammonium salt, and then upon heating, water will be removed, and then you'll get the product. And let me tell you the trick. Whenever if they give this acid and ammonia, you just do one thing. What you'll do, you just write this ammonia like NH2 and one more H like this, then you can simply remove water. Okay, as they mentioned this heat, so water removal takes place. And just add this just make a bond between carbon and nitrogen, so you'll get this product. So this is the trick that you can use in order to write the product easily. This will be C double bond O NH2. So we have got this benzamide, right? So this is the benzamide which they have given in the option itself. So this is the our product Q. And in the next step that we are doing this Hoffman bromide degradation. What happens exactly in this? So I have explained you with one trick, right? Like you can say this Hoffman bromide degradation as happy birthday reaction. Like just one low, like just think like this is whole cake and the C double bond O as a candle. So after while cutting the cake, you will remove the candle, right? So just remove the C double bond O. That's it. So this is how you can use the some sort of tricks in order to remember the reactions. So just remove this C double bond O bus. So this is your candle. Okay, so here it will be, we'll get the simple aniline. So that's what they were mentioning. And here we have got R as aniline only, and here also they have given aniline only. So that's why option B is correct. So you can say this option B is correct option. And let's check option D also. Okay, so here they have given phenyl ethanoic acid. What is phenyl ethanoic acid? This will be CH2COOH. Okay, so this is phenyl ethanoic acid, or else you can also call it as phenyl acetic acid. Okay, and here if we do this reaction, first is aqueous NH3. The same thing, just remove water. Okay, minus H2O will be removed, and here we'll get CH2. Here we'll get amide. Okay, NH2. And you might have understood like one more carbon is extra over in this one more carbon is extra in this compound also. That's why this won't be the answer. So in the Hoffman bromide degradation, in the presence of this Br2KOH, what happens? This will, you will remove the candle, right? So this will be CH2 NH2. And if you compare the degree if you compare this one with the given molecular formula, they have here we have only 6 carbons, but here we have 7 carbons. That's why you can eliminate this option also. So our correct option is B. So yeah, I hope you have understood. Let me summarize once whatever we have discussed. Here they were asking about a compo, here they were asking about compounds P Q R. Okay, so here they have given first P, and they treated with aqueous and ammonia and heat, and we have got Q, and they have again treated with this Br2KOH, which is Hoffman bromide degradation. And I have also told you the trick how you need to solve. So here we have got Q, and then we have did this Hoffman bromide degradation. I have also told you the trick how you need to solve this. And then we have got then we'll get the product R. They have given the molecular formula. Okay, so as the given molecular formula C6H7N, we have did the reverse engineering. We have got to know that R will be aniline. Okay, and we have checked the options. From this we have eliminated the options, accordingly, and then we have got the right answer. Okay, so this is how you need to check each and every option, and you can eliminate easily. Okay, I hope you have understood. For explaining you, I took this much time, but if you solve it by your own, it won't take that much time. Okay, so yeah, that's it. We'll solve a few more questions, and if you think these videos are helping you out, please let me know through the comment section. That gives me some sort of motivation to create even more videos. Okay, so that's it. Just take care of yourself and be kind. Bye.